This video is going to look at solving a basic trig equation, both by using the unit circle and for problems where you would need a calculator. Really what we need to think about now is if we have the trig function on the left, so like the sine of x, and we know what it's equal to, so if we know the sine of x equals -1/2, we're going to be solving for the x value this time. Okay? So let's look at an example. It says, given any equation, there will be two answers on one revolution, and that's because within the unit circle, there's always two of the same answer. So for example, it says sine of theta equals -1/2. So we're trying to solve for which thetas is that true. And again, there's two times in the unit circle where sine is -1/2. As I talked about when learning the unit circle, I actually always think about quadrant 1 first, and I think about when does sine equal just +1/2 in quadrant 1. And I know it's when the opposite side is short, so it's at the 30 degrees or pi/6. So I'm going to think about those reference angles because that's when I have the ordered pair of √3/2 for cosine and 1/2 for sine. Now, the second thing I have to do is figure out what quadrant sine is negative in, and that's why we have this note of it's helpful to draw the quadrants. Well, since sine is the y value, I know that sine is negative in quadrants 3 and quadrants 4. So when I process through that, then I know my final answer is when the reference angle, which again is the angle from the x-axis, is 30 degrees from the x-axis over here and 30 degrees from the x-axis in quadrant 4. So since I know halfway around the circle, my first answer, if I was asked to find the answers between 0 and 360 degrees, that would mean that I needed in degrees. I would do 180 plus 30. So one of my answers is 210 degrees. The other one, I know this is 30 away from 360, so I would do 360 minus 30 degrees. So it's at 330 degrees. And again, if you know your unit circle well, you wouldn't even have to probably calculate those. Please note though, if I did say to put it between 0 and 2 pi, that would mean I'd want the answer in radians. And so as we talked about over here, this is 30 degrees or pi/6, which means in radians, these are pi/6 away. So this would be pi, so I would do pi plus pi/6. Or pi/6 plus pi/6, so 7 pi/6 is 1. And then this is pi/6 away from 2 pi. I would do pi minus pi/6, which gives me 11 pi/6. So depending if I wanted the answer in radians or degrees, those would be my answers. But again, you should have two answers if we're talking about a full revolution circle and there's no additional restrictions. Another example, I could give you secant of x and figure out when that equals -2. Now you'll notice in this case I did say to solve it for when it's between 0 and 2 pi, so I'm only going to worry about radians. And secant isn't my favorite to work with because it's not straight from the unit circle. It's function of x. And since it is the reciprocal function, I take the reciprocal of 2 or -2, which is -1/2. So really I'm figuring out when does cosine of x equal -1/2. I'm going to switch the order of what I do things right now. I'm going to figure out which quadrants cosine is negative in, which is quadrants 2 and 3, since it's the x value. And then I quickly analyze in quadrant 1 so that I can think of where it's at. And again, it's when the adjacent side is short, so it's right here, which is at the pi/3 angle. So now I use that reference angle, and in quadrant 2, it has to be pi/3 away from the x-axis. That x equals 2 pi/3. And then the other one would be pi/3 past the pi, past pi. So that would be 4 pi/2. So it's kind of like putting a puzzle together because you have to figure out what those different values are. So those are my two answers there. Sometimes you're working with non-unit circle angles, and when that happens, you want to find the angle using the following functions on your calculator. You're looking for sine inverse, cosine inverse, and tangent inverse. Scientific calculators have those. They do not have secant, cosecant, and cotangent, and so we'll talk about how we would do that without a graphing calculator. So when I look at these next examples, Oh, sorry, before we get to that, we're going to do guided practice 11A. So pause the video and try these and then start it again to check your answer. For guided practice number 11A, I knew that I needed in quadrants 1 and 4, so I got pi over 4 and 7 pi over 4. And then tangent of x is negative root 3 over 3. That one's a little harder. I think through that if I end up with the negative root 3 over 3, I need the sign on top to be negative 1/2 and the cosine on bottom to be a root 3 over 2, or I need one of those to be positive, one need to be negative. Tangent I know is negative in quadrants 2 and 4, so those are my two situations. But the reason I know this is because I kind of mentally work through the math. I know that when I simplify that, that's when it's 2 over root 3. It's when the root 3 is on the bottom, which is when I end up with root 3 over 3. So the sine is 1/2 and cosine is root 3 over 2 at the over 6. So they're pi over 6 away from the axis. So those were the two reference angles I used, and I got 5 pi over 6 and 11 pi over 6. Okay, sorry, my slides are out of order, but now we're going to look at what I talked about before we did this guided practice, which is how we would do ones that weren't on the unit circle on our calculator. So if I have a non-unit circle angle, and this is in radians, because it's just a number, it doesn't have a degree symbol, or it's asking me to find the radians, I should say, then I'm still going to find two answers. Now, I need to find when tangent of x equals 1.3. The only way to do that on my calculator, I need the x and the y to flip-flop, so I need to do x equals tangent inverse of 1.3. I'm only able to pull up a graphing calculator on my screen, so hopefully you guys will figure out how to change the modes on the scientifics. But if I come here, make sure you check your settings. You go settings, document settings, and you'll see that my angle's in radians. If it's not, or if you want it in degrees, you click on it, switch it, and then make it the default. But mine is where I want it to be. So I'm going to save that. I'm going to go to a new document. No, I don't want to save anything, and I'm going to add a calculator. And again, what we were looking for was tangent, so I go to my trig button, but the inverse tangent of 1.3, and you'll see I get an answer of 0.915. When I type that into my calculator, I got x equals 0.915. So we're looking for the two times that tangent is positive. Because I got a positive answer, so that should be in quadrant 1 and quadrant 3 actually. And what we just learned is that this angle measure in radians is 0.915, so it has that as a reference angle. You'll see that I did calculate what the 4 key values are in radians as well. And so now I know that this reference angle also has to be 0.915. So for my second angle, I'm going to take the 3.14 plus 0.915, and I got 4.055. My two answers in this case, I find them the same way in the end. I just, instead of knowing the first one on my circle, I actually just calculated on my calculator. Next example, cosine of x equals negative 0.669. Again, we're going in radians. I need two answers. I know cosine is negative in quadrants 2 and 3. Okay, so in my calculator, I do cosine inverse of negative 0.669. I'll pull that up again. Trig, cosine inverse of negative 0.669. Enter, and you'll see that I get 0.3. Round it to one decimal place this time. So I get x equals 2.3. So like we saw on the last slide, this was 1.57 and this was 3.14. So hopefully it makes sense that this is 2.3. But remember, that's the angle measure from the positive x-axis. That does not give me the reference angle. So if I want to figure out this angle right here, I need to take the difference of 3.14 and 2.3. So I do need that reference angle. It takes me a little bit extra work. 3.14, I get 0.84. And then again, my other answer comes from quadrant 3. It needs a reference angle of 0.84. I get plus 0.8. And that one gave me 3.98. Those are my two answers there. And last but not least, we do have to understand how we can do these problems if we have reciprocal functions. And we're going to do that by using the reciprocal function. So cosecant is the reciprocal function of sine of x. And again, we are allowed to just take the reciprocal of the answer to go back and forth. So since technically this is 1.5 over 1, I'm going to do 1 over 1.5. So I'm going to figure out when sine of x equals that. I'm going to x equals sine inverse of 1 divided by 1.5. Now we are talking about when sine is positive. So we should be looking for an answer in quadrant 1 and quadrant 2 because it's my y value. So I'm going to go to my calculator. This time I'm going to do sine inverse 1 divided by 1.5. And I get 0.7. Rounded to that this time. So I got x equals 0.73, which does in fact fall in quadrant 1. So that's nice because it is a reference angle as well. And then my last thing that I would do is find the reference angle here. And I know this is 3.14. So to find this angle, I would do 3.14 minus 0.73. Go back to my calculator. I hadn't calculated this. 3.14 minus 0.73. I get 2.41 as my, sorry about that, 2.41 as my second. Those two answers. All right. Next thing I want you to do is, again, pause your last guided practice from this part, so 11b, and then check your answers. Now these did say to do degrees, so I do want to quickly review how I would change my calculator. So I would go back to the home button, go down to settings, document settings, document settings, radians to degrees, and then make default, okay. And now I'm just going to open a new document. No, I don't want to save. I have a calculator. So this time you should have done sine inverse of 0.27. And you'll see I get 15.66. So you can see how it changes it and gives you 15.66 degrees as the first one. And again, sine is positive in the first quadrant, 15.66. And so this reference angle will be 15.66. So with degrees, you would just do 180 minus that. I got 164 degrees. And then finally, when I did secant, again, I did cosine of x equals 1 over negative 4.339. And so I got 103.3 degrees and 256.7. All right, that's a good background. You should have the information you need now to complete assignment number 4, which is worksheet C, numbers 1 through 12 all.